right, rock stars, I apologize that I'm out today. I wanted to make a video so that you would have this to go along with the notes as you copy in the partial note sheet. We're starting this unit with arithmetic sequences. And you may remember this from Algebra 2. A sequence is a function whose domain is the set of natural numbers. So we have notation for this new function, which says to use n instead of x and a sub n instead of f of x. So in other words, if my function was f of x equals 1 over x, we would say a sub n equals 1 over n in sequence notation. So it's similar to functions in that you have an input and output value. So I'm going to write that. Similar to functions, terrible writing, sorry. You have an input and output values. Okay, and then also sequences have limited input values, so they're generally integers. So we say sequences have limited input values. Limited input values. 1, 2, 3, 4, etc. ... Okay, so this graph next to you, let's say 2 tick marks was a half, 2 more was 1, so then I had 4 tick marks, 1, 2, 3, 4, and so I had a 2 at the top. And let's say my scale at the bottom was 2, 4, 6, 8. And let's say I have a value somewhere here, somewhere here, somewhere here, somewhere here. We do not connect the points because the sequence is the domain of all natural numbers. So do not connect points since sequence has domain as set of natural numbers. 1, 2, 3, 4, 5, 6, 7, etc. Natural, numbers. Okay. Arithmetic, by definition, a progression, a pattern in a sequence of values, has a difference between these consecutive terms that are the same. So you probably remember from Algebra 2 where we say arithmetic is add and subtract between terms. We'll get into geometric next class. That's multiplying and dividing. But for now, we're dealing with arithmetic only. Excuse me. So in this first example, it says determine if the sequence is arithmetic or not. So we have this 8.7 and 9.9. If I take 9.9 minus 8.7, I'm going to get 1.2 difference. And so if I look at 9.9 to 11.1 and I can add 1.2, then I have the same common difference as 11.1 to 12.3. So we say this is arithmetic since the common difference is always 1.2. Is always 1.2. Okay. The next one has these squiggly brackets around S sub n. You might remember that when you were in Algebra 2, S sub n stood for a series. A series is made up of sequences. But in this case, we are looking at this set of values that our notation is S sub n, and the rule says it's 7n plus 2. So the way to find out if it's arithmetic is you would have to look at the term either right before it or right after it. So we look at the one before it and we call it s sub n minus 1. Therefore, it's 7 times n minus 1 plus 2 gives me 7n minus 5. So if I wanted to find a common difference to determine if it's arithmetic, I would say, oh, let's take s sub n minus s sub n minus 1, which means I'm going to take 7n plus 2 minus the 7n minus 5, and I get a value of 7. It is arithmetic because the common difference is 7. So to be arithmetic, it has to be the same difference between each term. And we have a common difference of 7 in this formula. Okay. The next section simply says, well, write down the first 5 terms. And part of you was probably looking at this and saying, what? No, all you need to do is substitute your value for n as the number for that term in the sequence. So in other words, if I want the first term, then n is 1. So a sub 1 is equal to 2 times 1 plus 1 over 3 times 1 is going to be 3 over 3, or 1. Okay, so my first term in the sequence is 1. The second term, using the rule, 2 times 2 plus 1 divided by 3 times 2. So I have 4 plus 1 is 5 divided by 6. A sub 3, I'm going to plug in 3. 2 times 3 plus 1 over 3 times 3 looks like 7 over 9. And a sub 4 is going to be 2 times 4 plus 1 divided by 3 times 4. So I'm going to have 9 over 12. And a sub 5 is going to be 2 times 5 plus 1 over 3 times 5. So I'm going to have 11 over 15. So my sequence using this rule is 1, 5 over 6, 7 over 9, 9 over 12, 11 over 15. And what it's asking is, what are the first 5 terms? So the first 5 terms in the sequence are what's represented in the squiggly bracket. All right, moving on. We have another rule, and this time we're going to plug in 1, and we get negative 1 to the 0 times 1 over 2 times 1 minus 1, which is going to equal 1. B sub 2 is negative 1 to the first, and I'm going to be multiplying by 2 over 2 times 2 minus 1. So I had negative 2/3. B sub 3, negative 1 squared. And I'm going to have 3 over 2 times 3 minus 1. So that's going to be 3 over 5. B sub 4, I'm going to have negative 1 cubed. And I'm going to have 3 over 2 times 3. Sorry, I'm skipping 1. Sorry, 4. Crazy. This will be 4 over 2 times 4 minus 1, which is going to equal negative 4 over 7. And then finally, B sub 5 equals negative 1 to the 4th, and it would be 5 over 2 times 5 minus 1. So that's going to be positive 5 over 9. So my sequence using this rule is simply 1, negative 2/3, 3 over 5, negative 4 over 7, and 5 over 9. And you may look at this as just a plug and chug, which it is once you have the rule. However, it is helping you determine the first 5 terms in a sequence that's arithmetic, where there's a common difference. All right, moving on. It says the nth term of an arithmetic sequence. All right. Well, we know that from Algebra 2 that there was a formula a sub n equals a sub 1 plus n minus 1 times d. And if you had me for Algebra 2, you heard me sing it a little with that inflection, because I would want to know how to determine that rule each time. Well, the variables that are used in this rule are a sub 1, which is the first term, n, which is the number of terms, and d, which is the common difference. So let's see how this works. Find the nth term of an arithmetic sequence if the initial term, and it should say a sub 1, is 5. Okay, so a sub 1 is 5. The common difference we say is d, is negative 1 over 8. Well, we say, okay, we're using the rule a sub n equals a sub 1 plus n minus 1 times d. And we're going to plug in what we know. So a sub n equals a sub 1 of 5 plus n minus 1 times the negative 1/8. And then with any rule to arithmetic sequence and series, we are going to distribute and simplify. So this becomes negative 1/8 n plus 41 over 8. Because you've got plus 1/8 and 5, which is 40 over 8. So you get 41 over 8. So your rule is a sub n equals negative 1 over 8n plus 41 over 8. Now, the nice part of finding the rule is if it says find something else, you're using the rule. So this one says find the 26th term in that arithmetic sequence. Well, n is 26. Sorry, highlighter still. They're telling me n is 26 because they want the 26th term. They're telling me to look at this common difference. So I guess this is not related to section B. We're looking at another sequence. So we look at this and we say, okay, to get the common difference, we're going to take the second term minus the first term, and we get negative 6. So that means within each term of this sequence, we're going to be subtracting 6. Our first term is the 17. So we come over and say, okay, a sub 26 equals a sub 1 plus 26 minus 1 times d. So a sub 1 is 17 plus 25 times the negative 6, and we get a value of negative 133 for a sub 26. Okay. Next page. So the first page was about arithmetic sequence and series. The second page refers to recursive. So think of words that start with rewind, repeat, redo, review. In other words, go back and do it again. Recursive is basically when you're in the middle of a sequence and you go back to one of the parts of the sequence before. So it uses one or more terms that precede the nth term. So you must be given the first term or first two terms. Okay, so the first problem says, write the first 5 terms of the recursively defined sequence. So just be careful. It's a plug and chug. And most students do fine, but you got to pay attention to the a sub n and the a sub n minus 1. So in other words, our a sub 1, they tell us, is 3. To get a sub 2, we're going to take 4 minus a sub n minus 1. So 1 minus 1 would be your a sub 0. We don't have an a sub 0. So the problem is we're not starting with 1. We're actually going on to 2. They gave us 1. So they had to give us the first term for us to even use this rule because we don't have an a sub 0. So this is 4 minus a sub 1, which is 4 minus 3 or 1. A sub 3 would be 4 minus a sub 2, which is 4 minus 1 or 3. Our a sub 4 is 4 minus a sub 3, which is going to be 4 minus 3 or 1. And our a sub 5 is going to be 4 minus a sub 4, which is 4 minus 1, or 3. So our first 5 terms are 3, 1, 3, 1, 3. So it oscillates back and forth. So don't think that just because you're given a rule that it's going to wind up being a progression of numbers or a decrease of numbers. The next one, they're giving you 2 terms. So this one, they gave you 2 terms. The first one, they gave you 1 term. So when you look at this rule, you can't use this rule unless you have the first 2 terms. So a sub 1 is 1, a sub 2 is 1. So when I go to a sub 3, I'm looking at a sub 3. A sub 3 equals a sub 1 plus 2. So a sub 1 plus 2, which means I want a sub 1 plus a sub 2. So 1 plus 1 is 2. Look at the subscripts to help you. A sub 4 is a sub 2 plus 2. That's a sub 4. So that's going to be equal to a sub 2 plus a sub 3, which is now going to be 1 plus 2, or 3. A sub 5 is going to be equal to a sub 3 plus 2, which is going to be equal to a sub 3 plus a sub 4. So you're going to have 2 plus 3, which is 5. So your sequence is going to be 1, 1, 2, 3, 5. Again, the hardest part, even though it's a plug and chug, is to keep track of those subscripts. Notice, even though you were doing 3, 4, 5, it's what summed up to 3, 4, 5. Okay, moving on. Next problem says the 5th term of an arithmetic sequence is negative 2. The minute I read that, I say, oh, a sub 5 then is negative 2. The 13th term, okay, that's a sub 13, is 30. It says find the first term and the common difference. So that's the first part, okay? So find the first term and the common difference. Well, we know the formula is normally a sub n equals a sub 1 plus n minus 1 times d. A sub n equals a sub 1 plus n minus 1 times d. So what we're saying is negative 2 equals, well, we don't know a sub 1. We do know that a sub 5, so the n is 5, is 5 minus 1 times d. Then we know 30 equals a sub 1 plus 13 minus 1 times d. So this sets up 2 equations. Negative 2 equals a sub 1 plus 4d, and 30 equals a sub 1 plus 12d. Well, remember back to your linear system of equations in Algebra 1, we would say, okay, let's try to eliminate one of the variables, because linear combination was also known as elimination. This would give me negative 32 equals negative 8d, because you would be distributing that negative to the whole second equation. So this would tell you d equals 4. And then you would come back and you'd say, okay, let's use one of the equations. So negative 2 equals 4 plus 4d, and solve for, so let's come back to this. I'm sorry. We don't know a sub 1, we just know d. So a sub 1 plus 4 times 4 is 16. And when you bring it over the other side, it makes negative 18, your a sub 1. So your formula for the nth term would be a sub n equals a sub 1 negative 18 plus n minus 1 times the d, which was 4. And then you would simplify it to be 4n minus 22. So there's your rule for the arithmetic sequence. They asked you to find a sub 1. So here's a sub 1. Here's your d. And then they said give a recursive formula and they said, what's the nth term of the sequence? So we've already actually done number 2. So this was actually the second part, was to find the nth term. The first part was to give the recursive formula. Well, remember, recursive just means go back 1. And as you go forward, if it's an arithmetic, you're going to be adding your common difference. So the recursive formula is actually pretty easy to write because it's a sub n equals the term that came before a sub n minus 1, and then add that common difference. So there's the answer to the first part. Okay, rock stars, we're almost done. Now we look at the sum of n terms. Okay, here comes that s sub n. Remember, a sub n is the rule in the arithmetic sequence, and a sub 1 is the first term and common difference is d. So what they want to show is that you have a formula for the sum of all your terms in the sequence. And for arithmetic, we're going to say take the average of the number of terms, so n divided by 2, and take the first term plus the last term. And there is your sum. We use this one more often. On your formula sheet, you're going to see another one. And we never use that one, so I will point to it when I'm in class next class, and you can ignore that second formula. Okay, so find each sum. All right, well, the first thing we have to do is determine if it's arithmetic. So we look at the second term minus the first term, and we get 4. So if we can add 4 to 3 and get 7, then we know the common difference is 4 for every term, and therefore it's arithmetic. A sub 1 is negative 1. Our rule would be a sub n, and normally we'd have to figure that out, but because they're telling us the nth term is 4n minus 5, they've already done the work for us. So our sum, s sub n, is going to take the number of terms, which we don't know, so n over 2, times a sub 1, which is negative 1, plus the nth term, 4n minus 5. So we're going to get n over 2 times 4n minus 6. And if we take a 2 out, we're going to simplify this to be n times 2n minus 3. And we're done. All right, next one. We look at the difference. So d would be 5 minus 2, or 3. Looks like 5 plus 3 is 8. A sub 1 is 2. A sub n is the nth term, so that equals 41. So now I'm going to say, okay, I need a sub n. I only know the value is 41, but I don't know the number of terms that I have to use on the outside to take the average. So I'm going to use this 41 that I know, and I'm going to say 41 equals a sub 1, which is 2, plus n minus 1 times the d, which is 3. So I'm going to get 3n minus 3 equals 39. So 3n equals 42. So n equals 14. So my sum, s of 14, is going to be 14 divided by 2 times 2 plus 41. And I'm going to get an answer of 7 times 43, or 301. So my s of 14, the sum of the 14 terms, are going to be 301. Last one. D equals the 7.3 minus the 5.4, and you get 1.9. Your a sub 1 is 5.4. Your a sub n is 32. So I want to find the number of terms, and I'm going to take 32 equals 5.4 plus n minus 1 times the 1.9, distribute and simplify, and I get 26.6 equals 1.9n minus 1.9, and I solve this and I get n is 15. So the sum of the first 15 terms is going to be 15 divided by 2 times a sub 1, 5.4, plus a sub n, 32. And we get the sum of the first 15 terms is 280.5. And that is the end of the notes today. Your substitute is going to give you an exit ticket and you're going to complete that and then hand it in. You can work in your table groups on that, and then she will give you the homework to take home and practice. Thank you so much for listening to the video, and hopefully completing the notes made it easier by watching the video.